Okay, this is the differential equation problem from 2021. It says y equals f of x be the solution to the differential equation that's given with the initial condition f of 1 equals 4, and it also gives us the second derivative, which is 4. So we need a second degree Taylor polynomial for f at x equals 1. So this is going back to series stuff. So if you remember, the way we create a Taylor polynomial is we start with the function at that value, which is 1 that we want, because we want it about x equals 1. They need the first derivative, and remember, it's about x equals 1, so you want x minus 1. And we want the second degree, so we need to get all the way to the second degree, which is x minus 1 squared over 2 factorial. So this is what we need to try to figure out. Okay, f of 1 is given, which is 4. F prime of 1 is not given, but f prime is really the same as dy dx. And I want to know what happens at 1 comma 4. So if I plug in 1 comma 4, I have 4 here. X is 1. Natural log of 1, which is 0. So your first derivative is going to be 0. So f prime is 0, which I don't really need to write. I'll get rid of that later. And then the second derivative they told us is 4. And then I have x minus 1 squared over 2 factorial. So really, this is my second degree polynomial. So it's a point for getting that correctly. And then it wants me to use that to evaluate f of 2. So this is an approximation. So I'm just going to plug in 2 in for x. And you could leave it like this, or if you evaluate this, it's exactly 6. So that would be your second point. Okay, part B is Euler's method. We're going to figure out what f of 2 is. And we're going to start with f of 1, which was given, which is 4. So it wants 2 step sizes, so that means I'm going to go up the x coordinate by 1/2. I start at 1, then go to 1.5, then go to 2. So remember Euler's method, all you're doing is writing the equation of a tangent line. So there's my point. I need the slope. And we already figured out from above, when we plugged in 1 into dy dx, we figured out the slope was 0. So the equation of a line is, remember, we're just writing this equation. So it's y minus 4 equals slope is 0. This piece, so in Euler's method, we're always trying to figure out y. So y should be the only variable that you have. Remember, this is your delta x, your change in x, so this is 1/2. But if I solve this for y, we get to 4. So my next point is going to be your x is going to go up by 1/2, so it becomes 1.5, and then this is my new y value that I got. So I need to calculate the slope here. So they gave us a formula for dy dx. It's y x ln of x. So if I plug that in, y is 4, x is 1.5, and I'm just going to leave it just like this. So y minus 4 equals, I'm just going to write all this out, 4 1.5 ln of 1.5, and then delta x minus x sub 1 is delta x, which is 1/2. So your y coordinate here would be 4 plus, move this 4 over, all of this. I'm just going to clean this up and make that a 2, but then everything else, I'll just write it like this. So I'm going to just leave my answer like this, whatever this answer may be. This is a non-calculator problem, so that's all you could do. And this is 2 points for Euler's method always. Usually the first point is for getting to here, and then the second point is for that. Okay, now the last piece is asking us to go ahead and solve the differential equation. So it wants us to find the particular solution, which is basically you are solving for y. So we are going to, anytime they ask you to solve a differential equation, we have to separate our variables. That has to be our first step. So this is the equation. So we want to get y's with the dy's, x's with the dx's. So my first step has to be this. Divide the y, and then I'm going to move the dx over here. Part C is the 5-point question. First point is separating your variables correctly. If you don't have this first point down correctly, then you're out of the running for the other 4 points. So you're 0 out of 5. So this point is very important. Then we're going to go ahead and take the antiderivative both sides. Antiderivative of the left is just natural log of y. Okay, this side, we are going to be using integration by parts. This is our UDV. So remember, for UDV, this is the LIATE is the acronym that you want to use to pick your U. So I see a log, so that's how I decide what to pick for my U. So I'm going to use natural log of x for my U, which is this piece. Anything else that you see in the problem should be your dv, which is going to be x dx. And then du is 1 over x. V is the antiderivative of x, is x squared over 2. So when you have something in the form integral of u dv, integration by parts is, this is the rule, uv minus the integral of v du. So uv, I'm going to put this in front, minus the integral of v, I'm going to pull out the 1/2, du. So that's my setup. I can clean things up. This is 1/2, this becomes x. And then now I can take that antiderivative pretty easily. So this is x squared over 2 here. And then obviously we have a plus c. Okay, I'm gonna clean this up a little bit. Make this a 1/4. Okay, so I get all the way to here. Next is we have to get this solve for y. So if you remember, we're gonna raise both sides to the e. So really it's e, all of this, but then remember this one, if you use properties of exponents, this is e to all of this times e to the c. So really that's another constant. So this can be simplified like this. And you do want to write it like this because this will make it much easier when you have to find that big C. So next step is solving for y. And the last thing you always want to do is plug in the point that they gave you. The point that they gave me was 1, 4. So I'm going to plug in 4 for y, plug in 1 for x. This is 0, so really I have c e to the negative 1/4 equals 4. So c is 4 divided by e to the negative 1/4, or you can write it like this, doesn't matter. So I'm going to take this and plug it into my c and write my final answer, 4 e to the 1/4 e to the x squared over 2 ln of x minus 1/4 x squared.